Hi, this is the revision session for ecosystems. Ecosystems falls within the Unit 1 paper, so you're going to see it in your first GCSE exam. It's in the section called The Living World, the second section, and it falls within that, and the title will be Ecosystems at the top of the page. This is what you studied at the beginning of Year 9. We need one case study, a local case study, and that will be the Rodwell Trail, which is a deciduous woodland, but more of that later on. Okay, the key idea from the specification, so we need to think about this at all times while we're revising, is as follows. Don't be overwhelmed by this. Take it one step at a time. Ecosystems exist at a range of scales. A range of scales means they can be really big or they can be really small. So you could have an ecosystem in a plate that you've left in your bedroom for a few weeks. You can have your whole ecosystem, a new ecosystem there, or it could be as big as a tropical rainforest. It will involve the interaction between biotic sounds like biology, living things, between living parts of that ecosystem and abiotic components. Abiotic, the opposite of biotic, not living. So what this key idea is saying is that there are big ecosystems and there are small ecosystems, and you need to understand that within each of those ecosystems there's living parts to the ecosystem and parts of the ecosystem that are not living, and they all link together to make that ecosystem work. Right, okay, so let's just get down to some of these key phrases and ideas. Okay, so if we take, for example, the case study, let's just go straight in. So we in Weymouth are going to look at the Rodwell Trail. We all know it. Your examiner may not know it, so you're going to need to write down Weymouth if you're writing an exam answer about that. The Rodwell Trail in Weymouth. Now, the Rodwell Trail in Weymouth is a woodland. Perfect. Now, within that ecosystem, if you're on the Rodwell Trail, so think about the bits where there's lots of trees, lots of smaller plants and animals and birds. Within that ecosystem, we need to break it down and think about the components. So if you think about the components of, say, a computer, you've got lots of different bits. Ecosystems are just the same. So within that ecosystem, you might have some trees in the ecosystem. You might have some plants. There'll be lots of roots underneath. You might have some fungus, a few little mushrooms there. There'll be some worms. There might be some little ants. You'll have some birds. You might have a fox. Oh dear. Here we go. Okay, so you might have a fox there. Okay, that's not bad. A fox. You might have some bunnies. So you might have some. Actually, we're in Weymouth. We can call them rabbits. Very bad rabbit. You might have all of those things going on. Now, within there, we're just going to have a think about what we're going to call these things. So these are the words that you absolutely need to understand. They might come up in a question. They may expect you to know them and understand them. So these are key words. Everybody needs to know these. So some of these things are abiotic components, abiotic parts, and they are not living. Now, everything I've drawn there is living. So what do we mean by not living? What in that ecosystem is not living? Well, let's just add a few, maybe in the same colour as that, some things that aren't living. So what's going on there? We've got sunlight. We might have water coming down. Water is not living. It doesn't reproduce. It doesn't breathe. It doesn't respire. It's not living. What about underneath the ground? The soil is not living. So the weather water. These are abiotic parts of the system. They're not living. Rocks, they're not living, but they are very important parts of the system. They all interact. It's all interacting together. Okay, so I think you'll know this already. Biotic components. These are living. So basically these are all the plants and the animals and the fungus and all of those other things. Quick note, people often get confused. So if it's a stick that's fallen off of a tree, is it abiotic or biotic? What do you reckon? Okay, so it will count as biotic because it came from a living thing. Same as if an animal has, this is the one that always comes up with students, poo, that will be biotic. A leaf that's fallen down, even though it's not attached to the tree anymore, that is biotic. The stick is biotic. So all of those things are biotic. And there are biotic things you can't see. So it also includes all of the bacteria and the microorganisms as well. Everything that's living, everything that reproduces. Think about what you learnt in biology, apply the same here. Okay, so far so good. We've got an ecosystem. We understand that it has bits that are not living, the water, the soil, the rocks, and things that are living, the plants, the animals, and everything else in it. We're going to break down this part now. This is really, really crucial. We need to understand this. So within the biotic parts, we've got 3 different categories. So some of these organisms are producers. Okay, so some of these organisms are producers, and producers can produce their own food, and they are the plants. Okay, so the producers are the plants. So if we could, over here, we could write down that these are producers. Okay, there we go. There's our producers up there. The second new word we're going to put in here, which you may well remember or have come across in science, are the consumers. Now, we are consumers. I'm a consumer, you're a consumer. These are animals. Animals that eat producers, and other consumers. Oops, there we go. Okay, so we've got producers and consumers, absolutely fine. So we've got the plants, and there we go with our fox is a consumer. Our rabbit over here is a consumer, and there's our producer, consumer. We're all good. There is another incredibly important component, and I'm going to write it down here. It starts with a D. Anyone know what it is? Do you know? Can you think? Okay, it's the decomposers. And the decomposers are another incredibly important part of this system, because without the decomposers, nothing would work. So the decomposers live on dead or waste material. Decomposers live on dead or waste material. So think about if you see a pile of dead leaves, or if you saw a bird that had died or whatever, there will be decomposers on there. So if you're kicking through dead leaves on the ground in autumn, you'll see mushrooms, and you'll see worms, and you'll see woodlice. And you won't see, but they are there, micro organisms like bacteria, and they are breaking down this dead waste material. We'll come on to that in a second. So just take a minute, look at those words, make sure you're happy, and we will move on. Okay, so the next part of what we're doing here is we're going to pull together some of what we've just learned in the nutrient cycle. Now, the nutrient cycle is super, super important. You're going to use it when you're talking about tropical rainforest. You're going to use it when you're talking about cold environments. It's one of those basic pieces of learning that you need to get your head around. It could well come up in the ecosystems, but it could come up in other parts. It's a building block to underpin your learning later on. So let's draw a tree. There it is, beautiful. And there's a leaf, and the leaf falls off the tree. Lands. Okay, now we see this all the time. It happens in the rainforest, it happens in the deciduous woodland frequently. So the leaf has fallen down. The leaf is now on the floor. It's a dead leaf. It's no longer attached to the tree. It's not going to grow anymore. It's there. It's full of nutrients. So in this case, let's choose a colour. I'm going to use pink because it will stand out. The leaf is full of nutrients. When it was on the tree, it's full of nutrients. The tree is full of nutrients. Nutrients are like the good stuff, goodness in the tree. Nutrients are there, and the leaf has fallen down. So it's now on the floor and it's lying there. If you remember what we were talking about just now, we said that there are certain organisms that will live off these dead leaves. So in this case, in comes some of these. So what do you think this is? A little worm, maybe a bit of fungus starts growing on there, and maybe some bacteria. And what these things do, these decomposers, break down the leaf. Okay, they break it down, they eat it. Basically, if you imagine the worm eats the leaf and then it poos out what's left over when it's taken what it needs. And as they do this, the leaf won't be there anymore. We know this, don't we? Because if you're kicking through those leaves, you can see the leaves are breaking down to smaller and smaller parts. And as the decomposers break down the leaf, this means that they are releasing nutrients into the soil. So the decomposers that were in the leaf, they're now not in the leaf anymore. They're in the soil. So the goodness that was in the leaf fell to the floor. The decomposers did their work, took what they needed, and then they've released it into the soil. Okay, so the nutrients are now in the soil. Decomposers have done what they need to do. And this is where the next part kicks in. So the tree, the bit that we don't often think about, underneath the soil there's the roots of the tree. And the roots of the tree need more nutrients to create more leaves. So they take up through their root cells, think about your biology, through their root cells, they take in the goodness, they take in the water, and they take in the nutrients. And the nutrients are taken in through the roots and they work their way up. We can do an arrow in the nutrient colour, up and up and up, and then create new leaves. So if we put here, roots take in nutrients. Watch your spelling there. Some people like to put a CE. Taking nutrients to grow new leaves. Okay, so that nutrients go down and down and they go back up, new leaves form, these fall down, more decomposers break them down, back they go into the soil, back into the roots, and round and around. And this is called the nutrient cycle. And it goes around and around. That is the nutrient cycle, and that is why the decomposers are so super important, because if the decomposers weren't doing their job, then the whole system would break down. Have a bit of a think, check that you understand that, have a look, draw it again, put it in your own words, write out a whole description so you can use this to help you. Make sure you could write it as a paragraph. Have a think, how could you represent it in a drawing when you're not looking at this, and make sure it's in your head, because it's a really, really important part of this unit. think about the different components involved. And if we think about that very, very first key idea, that's the interaction between biotic and abiotic components. And what you can see here is the biotic components, the producers, the plants, the trees, the decomposers, also biotic, they're living, and the soil, which is not living, abiotic, and there's something going on here. There's an interaction between these. So this is an important part of this unit. Okay, last but not least, well done, keep up the good work. Last but not least, we have this idea that we also have food chains and food webs, and we're going to think about the impact of changing one component. And I'm going to keep it super simple. You've done this in science food chains. This is a simple food chain. So we might have grass. We might have a rabbit. No giggling. Okay, there we go. And then we might have a fox. Okay, so it's Mr. Foxy Loxy with his big tail and his legs. Okay, there we have. So we've got an unconvincing rabbit and a fox. Food passes, energy passes between these. So if you think about science, you'll remember. Now, which way the arrow is going to go? Have a think. Had a thought? Okay, so the arrows go from the food to the rabbit. If you think in terms of the energy that is in the grass ends up in the rabbit, the energy that is in the rabbit ends up in the fox, and that's the way it goes. So just remind yourself, what do we call this kind of component? It begins with a P. A producer, and then we have our consumers. So producer and consumers in this situation. So you could call this a primary consumer and a secondary consumer, a top predator. You'll have had all of these phrases. Remember that food webs, and I'm not going to draw this. I'm just going to show you the picture. So if you remember on your revision guide, we've got this picture of a food web here. There's a food chain at the bottom there and a food web at the top here. So a food web is a much more accurate drawing of how food moves. So the reality is that the owl will eat quite a few different things, and some of these things will eat each other, and some of these things will eat grass, and some of them won't. And it's much more complicated than that. Okay, so a food web is a more accurate depiction, but a food chain is a more simplified version of how energy might move. And you could come across either of these, but what you do need to know is what will happen if one component is changed. So if you think about it, I'm going to keep this super simple and you can come up with some more ideas of your own. If in the Rodwell Trail environment, which is a deciduous woodland, it's a woodland with trees where the leaves fall off in autumn. So if the rabbits reduced in number, what might happen? So if we have less rabbits, what would the consequence of that be for the grass? Had a thought? Okay, we will end up with more grass because, and you would need an exam to explain why. Even though it seems very obvious, please state the obvious. So if there's less rabbits, there'll be more grass because there are less rabbits eating the grass. Perfect. If there are less rabbits, what does that mean for the foxes? Okay, so the foxes are higher up. The foxes want to eat the rabbit. What we have got here then is that if you remove the rabbits, if a number of the rabbits or the rabbits are reduced in number, the consumer that is higher up the food chain that relies on the rabbit for its energy there will be an impact on that animal. So what might happen? It might move to a different area, it might migrate, it may reduce in number, they may lose weight. So try and think about that. The thing below will increase and the organism above will decrease. You can then become more sophisticated and think about other impacts on a more sophisticated food web, as we see here. So other animals may therefore have more food who also rely on the grass, and that may mean that if you've got less rabbits, maybe you'll have more mice or something that eats the grass. So have a think about that. Think about food webs, think about food chains, and think about how changing one of these components, it might be the grass, if you take out the producers, what does that mean for the food web above? Not good news. If you take out the fox, what would happen to the number of rabbits if the foxes were reduced in number? Obviously you would have more rabbits because they're not being eaten. What would then happen to the amount of grass if you had more rabbits? So every time you remove or change a component, there is a difference for the whole ecosystem. Right, that is the first part of ecosystems. And if you are looking at your knowledge organiser here, what we've just covered is this section at the top, number 24 and 25 here. So again, go back, make some notes, make sure you're happy with the key vocabulary, and make sure that you understand that your case study is the Rodwell Trail. Well done, brilliant. Come and ask us if you need any help.